This is the first video in the series for Unit 3, Part 2 PowerPoint lecture notes covering electron configurations. When we think of electron configuration, we're talking about an atom. And everything we're talking about in chemistry, we're thinking of a system. And for any system to work, it needs to be energy efficient. And what do I mean by that? It means that the amount of energy going in should be less than the amount of energy that's coming out of the system. So in terms of atoms, we are thinking of the idea that atoms are going to place their electrons in a certain distance away from their nucleus that allows them to be energy efficient. So what we know is that electrons can be found in something what we call principal energy levels. Closest to the nucleus, we have n equals 1, n equals 2, and n equals 3. Now, for the Bohr model, you see we have the shells surrounding the nucleus. And if we want to know the number of electrons in each shell, is going to be equal to 2n squared, where n is principal energy levels. Okay, so if we want to know for n equals 1, that's going to be 2 times 1 squared is 2. So we have two electrons in energy level 1. And being that things have to be energy efficient, it's most efficient to have those electrons as far apart from each other, because you know that electrons are negatively charged, so they will repel each other if they're too close. So if we're thinking about the next energy level, see that we are able to put 8 electrons, and energy level number 3, able to put 18 electrons. So for ease, I'm just going to show electrons and energy level number 2. Now, that's the Bohr model of the atom. If we're thinking about the quantum model, we have the energy levels are broken down into sublevels, which then house orbitals. And this is a simplified version of the quantum model, but we'll take a closer look at each of these. Now, mind you, the electrons will be found within the orbitals, which is a probability in space where electrons would be located. So it's a three-dimensional probable location for electrons in a given orbital, or in a given, let's say, sublevel. The farther we move away from the nucleus, the electrons are higher and higher energy. As I mentioned in class, if we think of the atom as a mama, and electrons that are closer to the nucleus would be those electrons that, or the children that would be held on by their mom, by their hand, right? The farther we go away, these electrons have more and more energy, and they have more and more roam. They can, well, they're located in a different. As we move away from the nucleus, electrons have higher and higher energy. And we know this from electromagnetic radiation studies. Okay, so let's take a closer look at these energy levels and how they relate to our periodic table. So if we take a look here at our periodic table, we can see here that we have our energy levels. And notice that these principal energy levels relate to on the periodic table. You notice that the energy levels increase as we go down the periodic table. Okay? Now, if we want to take a closer look at where these electrons reside, let's use an analogy that can help us to think of how the sublevels and the energy levels are broken up. Let's say we were to represent the atom as a house. And as we go up this house, don't make fun of my house, but as we go up the floors on the house, each floor is going to represent an energy level. So here we are on the first floor. Here we are on the second floor. And here we are on the third and the fourth floors. So remember, N are the energy levels. And let's say down here is the nucleus. All right, in the basement. On each level, we have a room, and each room has a name. And each room is going to be considered a sublevel. So we have sublevels, and those are going to be the rooms on the floor. Now, these floors are special because each room or each floor has the same number of rooms that equals the number or the floor. So on the first floor, we've got one room. Second floor, we've got two. We'll describe the rooms as we go. So within that room now, let's say there's a bed in that room, and that bed is going to represent an orbital. Now, in the bed, there's special rules in the house where you can only fit 2 people in the bed, and they have to lie foot to head. So people are our electrons. All right, and they have to go in foot to head. Well, it makes sense because electrons are negative, and so they have to have opposite spins so that they can live in the same location. All right, so notice that we can put 2 electrons on the first floor. When we go to the second floor, there's also an S room with an S bed. And we also have a P room with P beds. And I'm not going to draw the P rooms with the P orbitals as they would look because, well, let's try. I'm not sure if you will be able to see the electrons when I'm done, but we'll try. Let's see if we can get some P orbitals in there. All right. If we remember orbitals, they can only have 2 electrons apiece. So we can have 2 electrons in the s orbital, 2 electrons in a p orbital, 2 electrons in this p orbital, and 2 electrons in the last p orbital. As we go to the third floor, we have an S room, a P room, and a D room. Now, in the S room, we've got s orbitals that we know can hold 2 electrons. We've got those p orbitals that each orbital can hold 2 electrons. And we've got d orbitals, and I'm just going to draw those as weird rectangles. And remember, for each orbital, you can put 2 electrons. So on the fourth floor, we've got a S room, a P room, a D room, and an F room. And we've got an S bed, 3 P beds, 5 D beds, and we've got 7 F beds. And I won't draw the electrons in the top, but you'll see. So notice we have how many electrons here on the first floor? How many electrons can be held on the second floor? Right, 8 electrons. How many total electrons can be held on the third floor? And if you do all the math and add everything up, let's see, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So we have 32 electrons that can go in the fourth energy level. Now remember, I was giving these names. So notice the sublevels have names S, P, D, and F. The orbitals also have the same name. All right, so you will only find s orbitals in a s sublevel. You will only find p orbitals in a p sublevel. You will only find d orbitals in a d sublevel, and so forth and so on. Let's think about these sublevels, and let's write out a plan based on what we were looking at on our periodic table. Let's make a table, and we're gonna look at the energy level. We're gonna look at the sublevel. We're gonna look at the orbital, and we're gonna look at the number of electrons. All right, on n equals 1, we have one sublevel. It's called a s, and we also have one s orbital, and we can have 2 electrons in that s orbital. When we move to the second energy level, notice that we have an s sublevel and a p sublevel. Here we have 2 s orbitals, and we had, how many did we have in our house? We had 3 p orbitals, excuse me. And we can have a total of 8 electrons. On the third energy level, we have S sublevel, we've got the P sublevel, and we've got the D sublevel. If you remember, we had, let me go back up here. There's one S sublevel. Let me fix that. Okay. Now, back up here, back down here to the third energy level, we have one S sublevel. We've got we've got one s orbital. We're talking about orbitals. We've got 3 p orbitals. And if you remember, how many beds did we put in the house on the D level? In the D sublevel, we had 5 d orbitals. And if we remember, we had 18 electrons. If we move now to the fourth energy level, we've got an s orbital, we've got an s sublevel, a p sublevel, a d sublevel, and an f sublevel. Within those sublevels, we've got one s orbital. In the p sublevel, we've got 3 p orbitals. In the d sublevel, we've got 5 d orbitals. And in the f sublevel, we've got 7 f orbitals. And in this energy level, we can hold a total of 32 electrons. Remember, we calculated that by 2n squared. So let's take a look at our periodic table. Notice here that we've got, on our first energy level, we've got 2 atoms on our first energy level. Notice that hydrogen is number 1. It's got 1 electron. Helium is number 2. It's got 2 electrons. Moving down the periodic table, notice we see here, energy level number 2, we've got 2 electrons in our S sublevel, and then we have 1, 2, 3, 4, 5, 6 electrons that can fit in our p sublevel. Notice that each atom, as the atomic number increases, that tell you that the number of protons increases. And because these are neutral atoms, the number of protons is going to be equal to the number of electrons. So, when we look now, let's go down to the fourth energy level. That's where things get a little bit tricky. Our D block, notice that there are 10 atoms in each period in the D block. These atoms that we see here, okay? Now, remember, the D's start in energy level number 3. So when we look here on the periodic table, we have to know that this set of atoms has electrons in the third energy level, starting in the third energy level. Okay? So, as we are thinking about electron configurations, these electrons are housed in these orbitals within sublevels, within energy levels. Now, as we move down the periodic table, notice that we start our f orbitals in our fourth energy level. So when we look down here, these atoms have electrons that are found in the fourth energy level. Okay? Now, we don't necessarily do electron configurations of these atoms. They get to be a little bit difficult. We will focus on our representative elements in groups 1, 2, and, well, 1A, 2A, 3, 4, 5, 6, 7, and 8A. And a few we will do in the D block.